Over the years, WISDM has become synonymous with efficiency and precision. This means that when customers use WISDM to evaluate if addresses are serviceable, they are getting the very best possible match using the very best possible data. Moreover, WISDM can also help them to operate efficiently. That's to say, use the lowest cost or the easiest installation method first of all, and if that doesn't work, then try a more complex or more expensive one. In this example, we have 4 client profiles in use. Each one of these profiles is tested in order to see whether or not an address is serviceable. This happens at an individual address, and it also runs with the very, very large scale, multi-million address reports. We have just 4 client profiles set up on this example, but we can have up to 30. Each profile can include a range of criteria such as the height at which we install, in other words, a cheap bracket versus an expensive pole, as well as signal behavior, signal characteristics, and even compatibility. That's to say, using this profile only with, say, millimeter wave, and using a different profile with different settings for, say, Tirana. If we look at this example, we're testing first of all for our preferred mount, which is a 1 meter pole around the edge of the building or the perimeter of the building. Because the edge of a building, it tends to be easiest to attach a ladder and to attach a bracket. If that doesn't work at 1 meter height above the edge of the building, we can try it at 2 meters, and if that doesn't work, it will try it at 50 centimeters on top of the roof, and so on. So we can have a progressively more involved, more complex test. When we run this in WISDM and see how that performs for an individual address, I can put in an address, in this case, Tyndall Street in Cardiff. WISDM finds that address and instantly does line of sight checks to all of the towers. Now in this example, we've got lots of coverage. So we've got lots of green lines. If I click on one, we can see the profile, and we can see that this was a building edge at 2 meters. The building edge at 1 meter test wasn't sufficient. It didn't meet the criteria I wanted, but at 2 meters it did. And if I zoom in, I can see around the outskirts of that house where the test points passed, and I can see the point with the strongest signal. If we look at an alternative tower, it may be that it uses a different profile. So if I explore, that one's all building 2 meter edge. And so are all of these. We can also scroll through them to see what it would look like on the rooftop or higher above the rooftop. In this example, 50 centimeters above the roof would be a failure. 2 meters above the roof would be a pass. And we can look at whereabouts on the roof we would need to go, the north elevation. So when the installer turns up, they know exactly where to go, and they know what signal level they should achieve in order to give the connection that is being promised.